The night sky looks peaceful, a grand cosmic ballet. But this tranquility is deceptive. We see immense islands of stars, entire galaxies containing billions of suns. The profound question is, what holds them all together? Why don't these colossal structures just fly apart? They're spinning at mind-boggling speeds. The stars on the outer edges are moving so fast that the gravity from all the visible matter, the stars, gas, and dust, isn't nearly strong enough to hold on. According to our understanding of gravity, they should be flung into the void. The math doesn't add up, but they aren't. The galaxies remain stable. This means something unseen is providing the extra gravitational grip, an invisible scaffolding that keeps it all together in a cosmic embrace. This cosmic glue has a name: dark matter. We call it dark because it doesn't emit, reflect, or absorb any kind of light, making it completely invisible to our telescopes. We can't see it, but we can feel its powerful gravitational pull across the universe. It's a mysterious, invisible substance our telescopes can't see because it doesn't interact with light. So how do we know it's there? Gravity. We see its influence in galaxies that spin impossibly fast, held together only by a vast halo of this unseen matter. Its gravity also warps space-time, creating invisible lenses that bend light from distant galaxies, revealing its presence. In the 1970s, astronomer Vera Rubin studied how galaxies spin. Prevailing wisdom said distant stars should move slower, but her data was shocking. Stars on the galaxy's edge were racing as fast as those near the center. This was impossible unless a huge amount of unseen mass, dark matter, provided the extra gravitational glue. Independent evidence from gravitational lensing confirmed it, sealing the case for dark matter. Dark matter's influence extends far beyond simply holding galaxies together. It doesn't just glue, it architects. While radiation smoothed out ordinary matter in the early universe, immune dark matter began to grow, forming vast halos. These acted as powerful gravitational wells, pulling in gas to ignite the first stars and galaxies. These halos linked up, creating the immense cosmic web, a grand design that dictated where everything could form. It is the ultimate silent organizer. Where certain dark matter exists, its gravitational pull is the invisible glue holding galaxies together, preventing stars on the outer edges from flying off into space. For decades, the leading candidate for this cosmic phantom was the WIMP, the weakly interacting massive particle. To hunt for it, scientists built incredibly sensitive detectors, burying them deep underground to shield them from cosmic radiation. The hope was that a WIMP would occasionally collide with an atom, leaving a telltale flash of light. But after years of searching, the silence from these experiments has been deafening. This profound lack of evidence has forced a pivot, pushing physicists towards a new, more ethereal candidate: the axion. The polar opposite of the WIMP, it's almost unimaginably light. Instead of individual particles, a vast, oscillating sea of axions could permeate the entire cosmos. The hunt is now on with new experiments, using powerful magnetic fields as a catalyst. The goal is to coax an axion into converting into a single detectable particle of light, a faint whisper that could finally solve one of cosmology's greatest mysteries. Everything we see, every star, planet, and galaxy, is just 5% of the known universe. The rest is a profound enigma. 27% is dark matter, the invisible cosmic scaffolding that provides the gravitational backbone for galaxies. Without it, they would fly apart. The remaining 68% is dark energy, a mysterious repulsive force causing space itself to expand at an accelerating rate. This cosmic ignorance fuels a global quest. Telescopes map dark matter's gravitational effects like the bending of starlight around invisible clumps. Simultaneously, deep underground, shielded from cosmic radiation, hypersensitive detectors wait in silence, hoping to catch a single elusive particle as it passes through the Earth itself. A single detection would be revolutionary, revealing a whole dark sector of physics and redrawing our map of reality. The implications are staggering, and the search is on. To continue this journey into the unknown, subscribe and join our community of explorers. There's so much more universe to discover together.